Hi everyone, welcome back to question 2 of this week's practice. For this problem as well, we're graphing a trig function that has been transformed in some way. If we want to work through those transformations, let's go ahead and do that right now. So the 3 is actually a vertical stretch by a factor of 3, which changes our amplitude. The 0.25 is actually a horizontal stretch by a factor of 1/4, or a factor of 4 if we want to think about that in terms of the reciprocal. And then finally, -3 is a vertical translation 3 units down. For this case, what's different is we're looking at negative x values instead of only positive. So that's just going to make us rotate or work backwards in this function, or graphing of the function, instead of just working forwards. So setting this graph up, here's my x-axis. We'll worry about the units in a little bit. And then we're going to want more in the positive direction than the negative. So let's go about right here for my y-axis. So here's y. And we're going between 6 pi and -4 pi. So that looks about right. I'm not going to label my y-axis in this case because I don't want to mess with values. But if we start just setting up our y-axis in increments of 1, I know -3 is going to be my principal axis. So down 1, 2, 3. Right here's my principal axis. So let's go ahead and put a dashed line so we can keep track of that always. And then the maximum is 3 values above, since our amplitude is 1. 1, 2, 3 is 0. So this is going to hit a maximum of 0. And then our minimum is going to be 3 units below the principal axis of -3. So 1, 2, 3. -6 is our minimum value. So let's go ahead and put that into place. And there we have it. Now, part of the process why I don't have this set up ahead of time, even though I know what it looks like, is building this actually takes care of most of the transformations at once. So now all we have to worry about is what is our period, and when is it hitting one of those 5 key critical points of a maximum, of a minimum, and the principal axis is 3 of those 5 critical points. So there's actually 3 unique points, but we worry about 5 positions on the unit circle. So now we need to set up our period. So B is 0.25. That's going to determine what our period is. So as we've said in the past, to find our period, we take 2 pi and divide it by B, which in this case is 0.25, or 1/4. So since I don't have a calculator on hand, let's work through this. So we have 2 pi divided by 0.25, which is 1/4. Well, to work through this is actually 2 pi multiplied by the reciprocal, which is 4, so our period is 8 pi. So this is taking a long time to make it through one full revolution. It oscillates very slowly, or rotates, has very slow revolution, takes a long time. So 8 pi there. So getting through this, we are going to start by considering where 8 pi would be. Well, if 6 pi is our maximum, 8 pi would be one full revolution. So what part of a revolution or rotation around this unit circle are we? Well, if we're 6 of 8, we're actually 3/4 of the way through. So if we want to go halfway, that would be 2 pi, or 4 pi. So let's put 4 pi here, and then 2 pi would be 1/4. So we have 1/4, 1/2, 3/4, and then we will have one full period at 8 pi. So filling this in on the same scale, we would have -2 pi here. So we've basically done all the work now of worrying about when it hits certain points and what those points are. So cosine function, as we've said, always starts at a maximum value because it's the horizontal distance, and at 0, the horizontal distance on a unit circle is at a maximum value. So we start at 0 right here, at a maximum. Then we go to the principal axis. Then we go to a minimum. Then back to the principal axis. So we don't even have one full period here. Now if we want to work backwards, we are at a principal axis, minimum, principal axis, maximum, principal axis, minimum. So we had to work backwards to graph these negative values. You can think about that as rotating the other way around a unit circle. So what we have in the end here is this curve. There's our maximum, there's our principal axis, there's our minimum, and then back to the principal axis. So this is going through 1 and a quarter revolutions, or periods, it looks like, actually. I hope this video helped. We'll look towards the 2 graphing ones in another video to come.